Okay, so we are going to talk about rotations, and let me grab some different colored pens first. Okay, should have been better prepared. Okay, so we're going to be talking about rotations. And we're going to be rotating about a point. So that means that we would have, let's say we would have a heart here, say this is our shape, and if we're rotating it, we are keeping it the same distance. So think of this as being maybe glued to the end of a yardstick or something, so that is still just going to keep rotating around here. So it's still going to be the same distance away from your point. So what I'm thinking of in my head is like those windmills that maybe look something like this. Okay, so this is what I'm envisioning, is no matter where we rotate it, it's still always going to be the same distance from this center point. This blade is not going to get any closer to this. Like this point right here, if we rotated it 90 degrees, would be the same thing as that point there. We have two types of rotations. We have a clockwise rotation, and that would be rotating it the same direction that a clock's hands move, so going that way. And then we have a counterclockwise rotation. And that would be going the opposite way that the hands move on a clock. So for our purposes, we're going to be talking about like increments of 90 degrees. So we have 90 degrees, we have 180 degrees, we have 270 degrees, and we have, and this could go either clockwise, so CW, or counterclockwise. 180 degrees, typically there's not a CW like a clockwise or a counterclockwise because it's the same no matter which way that you go. So meaning, if I have a point right here and I rotate it 180 degrees, it's going to end up here no matter which way I go. So you need to know that 90 degrees clockwise, so 90 degrees the direction of a clock, would be here. And that is the same as 270 degrees counterclockwise. So let me say that again. 90 degrees clockwise, which is the yellow, is the same thing as 270 degrees counterclockwise. Okay, so those are just the basics of rotations. We are going to be rotating on a coordinate plane. So I think the easiest ones to start off with are rotating 180 degrees. Just like anything else, there are patterns and rules that you could memorize. I still think it's really important that you understand where it comes from, though. Okay? So if I have a rotation of 180 degrees, what I like to do is to have a ruler and a pencil. And because we are rotating about the origin, I am going to draw all of my, let's see if I want to use this one. Let's see if there's another shape that I want to use. I'll use this one instead. It's fine. Okay, so I'm going to draw from my point through the origin, which happens to be right on that axis, from point J through the origin. I'm going to draw that line really light. And H through the origin, I'm going to draw that line fairly light. So I know that if I'm rotating it 180 degrees, J is over here. J better end up over here on this line. H is on this line, so my new H or H prime better be also on that line because I'm rotating 180 degrees. Okay, so I like to think of these in relation to slope. So if I look at the slope of, this one's actually an easy one because it's already on an axis. It's 1 unit from here, so Q has to be 1 unit from here. So there's Q prime. That's an easy one. J, I know J prime is going to end up over here somewhere. So because we're on the same line, this line has the same slope. So if I go up 3 and to the right, 1, 2, 3, 4, 5 to get to my origin, I'm going to do the same thing to find J prime. Up 3, to the right 5. 1, 2, 3, 4, 5. So like I said, J prime better be on the same line as J because we're rotating 180 degrees. H to the origin, if I go up 5, 1, 2, 3, 4, 5, and to the right 3 to the origin, I'm going to go up 5, and to the right 3 for that one as well. Now I can take my pen and with my straight edge, Q is right there. Okay, so that's what it would look like if I rotated this 180 degrees. So now we're going to rotate 90 degrees. So whether you rotate 90 degrees clockwise or counterclockwise, it's still the same process or procedure. Okay, so I'm going to do this kind of the same thing that I did before. And I am going to draw a line from S lightly through the origin, and from B lightly through the origin, and from my point L lightly through the origin. Okay, so if we're rotating 90 degrees, remember we're going to have those perpendiculars in there. So I'm going to do a quick review of perpendicular or slopes of perpendicular lines, and that would be that they are opposite reciprocals. So opposite reciprocal slopes. Okay, opposite reciprocal slopes. So if I go up 2 from the origin, up 2 and to the right 2, if I do the opposite reciprocal of that, that is going to be down 2 and to the right 2. So if I went down 2, that would be from the origin, down 2 and to the right 2, that would put me right there. So let's think about that. 90 degrees counterclockwise. So if I rotate this, that means this figure is going to be rotating this way. So this point better end up over here somewhere. So instead of going down 2 and to the right 2, I can go up 2 and to the left 2. So there is my S prime. So I am going to show you how you can tell if you are on the right track or not. If I draw the line from S prime to the origin, and then the origin back to S, you better have a 90-degree angle. And I do. I'm going to do the same thing with B. To find B, I would go 1, 2, 3, 4, 5, 1, 2, 3, 4. So up 5 and to the right 4. Opposite reciprocal would be down 4 and to the right 5. Same thing though, remember when we have a negative, that we can move this negative either in the numerator or denominator. So if I went down 4, and to the right 5 is going to put me over here. Instead, I'm going to go up 4 and to the left 5. So B prime. If we would use this and we'd end up with B down here, that would be what we would use for rotating 90 degrees clockwise. So I'm going to take, use a different color than purple. And I'm going to draw, just so you can see it, I follow the purple, doing the same thing. So from B prime to the origin and B to the origin, there's my right angle in a light purple. And then from L, if I am rotating L, it's going to be, well, you can look at this as a slope, or just recognize that, hey, this is 5 units here. If I rotate it, it's going to be 5 units up here. And that would be my L prime. So now I have that figure. So if I rotated it, say if this was on like a fan blade or something, and I had this to begin with, and I rotated it, this is what the figure would actually look like. We will do some more of these in class, but this should get you started.